All right. Well, the hardware was driving me nuts, so I thought, well, maybe it's a bad chip or something like that, and tried to remember if I had some other platform that I could use to try to test things out on. And it turns out that I did. I have this nice board from what's the guy's name? Sergey Kislev. And it's a 8085 version. I had Tiny Basic in it, and I've got a bunch of videos on me building this board and troubleshooting it. And I remembered that it had an 8251 on it, so I could go ahead and write my own program and stick it in here and test my own program with an 8051. And so I did that. So this is my program in here, and sure enough, it worked just great. So I figured, okay, well, maybe that proves that the hardware is bad. I'm doing everything right. And so one thing I noticed on this board, though, was that the handshake lines were brought out. So this is the schematic for the for that 8085 board, and down here. I think you can just see that. The transmit and receive are brought out, but also RTS and CTS are brought out. And so I thought, okay, well, maybe I kind of thought that maybe you needed one of the lines pulled high on the UART chip. Anyway, those two lines were brought out, and they do seem to toggle, or they do seem to be active. So I figured, okay, well, maybe that's the only thing that I'm lacking then. So let me show you my schematic. Alright, so here's the schematic. I know it's hard to read, but the 8251. So I had brought out pins 2 and 3, but in additions, there's a request to send and a clear to send that come out to pins 7 and 8, which I didn't have originally wired. Those weren't there. So on this board, I added pins 7 and 8. So now the RTS and CTS signals do come through, and now my program works great. It echoes, and also while I type, the LEDs flash. So the software that's running right now is character in, output to LEDs, output to character out. So it's a feedback loop, and now it's all working great. So the board's up and running with serial, so now I can start working on my program for the monitor program. I did want to mention one thing. These LEDs turned out to be completely invaluable. I mean, they're so valuable to do all of this troubleshooting. So if you do have a board that you're building, make sure that you put in some way of getting an LED, at least one LED that you can talk to. You can do lots of things with this one LED. You can turn it on and off. You can blink it like 2 times or blink it 3 times. A lot of times you'll see people open up test equipment. There'll be LEDs just on the power supply, the +5, +12, -12. You can just glance down and look at it. If you're having problems with a lengthy program, put in breaks in the, not even breaks, but put in things in the software so that, like, if it makes it past subroutine 1, you light the first LED. If it makes it past subroutine 2, light the second LED. And so you can get kind of a running total of where in your software it works before it crashes, right? So these LEDs have been completely very valuable. I think I'll get the switches up and running too. Those can be valuable also, like if you want to get to a certain point and then make a choice. So I have, it's hard to see there on the back side here, but I have 4 switches, and I'll wire those up. I think the first program I'll write is read the switches and display them on the LED.
All right, so I've been writing some programs. It's kind of fun, kind of a Wayback Machine. So we've seen most of this before. Initialization, all of that was correct. I just needed to add those 2 wires. All right, All the initialization stuff is still the same. So here's what I've added. So now when it turns on, it comes here to the main and it outputs a couple sign-on messages. Um, the typical way to call the messages is to load the message pointer into the H&L registers and then call the message handler. Then I have a main loop here. So this is the main loop, and it's going to read the switches, the 4 switches I have hooked up to the parallel port. And if you push the first switch, it'll execute loop 1. If you push the next one, it'll execute loop 2. And if you press the third one, it'll execute loop 3. So 1, 2, 4. And loop 1 is an LED counter. So this is just a counter from 1 to 256 or 0 to 256. If you push the other button, it does a serial data echo. So whatever you type gets echoed. And then the last one, whatever switch you press, it displays it on the LEDs. These routines haven't changed. The show routine, I moved it to the complement out complement. That seems to work fine. Switches is easy. It just reads the A port. That's all it does. And then here's my little routine to print a message. The messages are an ASCII string followed by a 0. So it's going to move whatever is in memory pointed to by H and L, moves that into the A register. That doesn't affect the 0 flag, so you need to do something that affects the 0 flag. So you do an OR AA, which doesn't do anything at all, but it does affect the 0 flag, and then you're going to return on 0. So it's going to execute this loop until you get to a 0 character, which is the last thing in the string. You're going to then output that A register, increment your string pointer, and then do it again. So that's what it does. So let's go over to the machine and see if it executes.
Okay, let's see if it works. We'll turn the power on, and we get the message. It's asking us to press a switch. The switches are under here. I'm going to press switch 1. It says LED counter, and it's counting. It's set up so if I hit this last switch, it'll execute or stop executing and go back to the beginning. You've already seen the echo one, which is 2. I'll press the third one, which is echo switches on LEDs. So if I push the 1 switch, the 2 switch, both together, third switch, 1, 2, 3. And then if I push the 4th switch, it pops up. So yeah, program worked great.